This is Two Wheelbarrows in a Place We Call Home with Josh Carroll and Brent Rollins.
How you doing, Josh?
I'm good.
What are we doing in here today?
I don't know. They're saying that it's a different studio. It's a different place for us.
It is. It's a different studio with a different look and a different feel, and it's a new project.
It is. We're jumping down the new technology of trying to podcast and seeing how this works out for us.
Stepping right into the 21st century, kicking and screaming, right?
21st century?
Yeah, sure. Why not?
Let's figure out what we want to do here. So it's a new environment, new thing that we wanted to try out just to kind of see how this was going to go. Wanted to do a podcast and start talking about Concrete 101. Because we're finding out, a lot of people, it's either you got people who understand a little bit of it or people who understand a whole lot of it. And there's a lot of people out there who don't understand the difference between cement and concrete. And so this podcast was to kick off basically just Concrete 101 basics and just kind of walk through it and get everybody a different way. And this way we can get out to other people.
Sure. I think that's a great place to start, and we'll see what it can turn into and see how it grows. And I mean, not this particular episode, but if we do more episodes, see how it grows and see what it can, where it can lead. I mean, for me, today, the weather today is the perfect time to be listening to this podcast. I mean, it's cold and rainy outside. Most people aren't pouring concrete on a day like today. Might be a chance to listen in on a podcast or two.
True, or just driving up and down the road.
Yeah,
that's generally when I'm listening to my podcast is driving down the road or, whenever I got 10, 15 minutes that are free and just want to hear something a little bit differently.
Yeah, so for new listeners, new viewers, just wanted to recap our relationship, friendship, whatever you want to call it. I know relationship might make you cringe a bit, but I've known you for a long time, Josh. When did we first meet?
September of 93.
That's that puts a.
I don't know why you even asked that because that just made us really old really quick.
Sure enough, did. This is the first time we worked for the same company.
Yes,
we've both been here 6-ish years.
2017.
Okay. Yeah. So going on 7 years.
Yes.
Yeah. So
I've been here 7 years. You're almost there.
Yeah, I'll be here 7 years, I think, in May. And not just that though, but we've been friends a long time. But not only that, you're my brother in Christ,
yes.
And that's important to me that we share that, and that's something that we talk about often. So Josh and I talk about a lot of different things all the time, and it can range from politics to concrete to whatever. But here at work, concrete is the number one, our number one mission, and we were looking for something to talk about that would take concrete from the ground up. And, the question of where do you start is always a difficult question when you want to talk about a complex topic and you want to put it in terms that's accessible to the very first person who really doesn't know what concrete is, like you were saying, concrete and cement confusion, that kind of stuff, and build on something to provide some info, but have some fun while we're doing it. Hopefully we'll get to tell some stories.
Hopefully.
And yeah.
But I kind of want to pause for just a little bit and roll back. The name of this podcast.
Oh, yeah.
Two Wheelbarrows in a Place We Call Home. And you kind of started into the fact that, we've known each other a very long time. And, we're debating on what to call it. When you got to the home thing, it's one of those things where, you can buy a house, but until you put a certain effort into it before you start putting more into it, it's not really a home. It takes a little extra. And I know a lot of people who have jumped through different jobs and made a career out of this or a career out of that. And, back in 17, when I first started in construction, it was nowhere near on my radar. That's what I wanted to do for a living. Mm-hmm. I had dreams of being a marine biologist or something down the lines of being around the ocean. And, for whatever reason, chance, fate, divine intervention, I ended up dealing with construction materials and got into the concrete. And that really, jumped into me. Mm-hmm. And it's one of those things where training people is coming up out of the testing company because I was testing way before I got into the manufacturing, and I spent 25 plus years in it. Is when we bring somebody in new, is like, you got 2 weeks to figure out, and that's all it's going to take. Either this is in you or it's not.
Yep.
And there is something to be said for that. It's great. You can have a career and a wonderful job and you get paid and you come in but it feels like a grind.
Yeah.
And for what this is, we found home in construction. We found home in concrete. And more importantly, we found home at Spraylock that I don't regret coming in every day. I don't wake up like, man, I really don't want to go in today. I can't face it. It's one of those things where my drive to work, my drive home is much easier than it has been, before construction. I did work in fast food.
Okay.
And there were many of those days driving in and driving back home. It was just not the most fun experience for you. But everybody's got to find that home.
Absolutely.
And this podcast, Two Wheelbarrows and a Place We Call Home, is really, for me, is going to go into why we do what we do, why we love it.
Absolutely.
And it goes back to, and we've done the videos and, you check them out on YouTube or LinkedIn and we get into our why. Why are we here? Mm-hmm. And one of the things that for me, it was growing up and being told when I walked out the door, don't forget who you are. Mm-hmm. Remember your name. And it's one of those things where I'm never going to be rich enough to have my name on a park bench or a building or anything like that. But everything I've ever touched, that is going to set something there. That is my legacy. And, short of my kids and what I'm passing down to them, which gives them sustainability and how we're leaving the world a better place, that's really where we're at.
Yep.
Our home is what we're leaving somebody else. And so my name and everything I touch, that's why I'm doing what I'm doing today.
Yep, and for me, it was sort of an accidental getting into the business when I was 16 years old, working summers. Wanted to go to work in an air-conditioned place, bookstore, movie theater, but...
Construction sites are air-conditioned, after everything's done from what we were doing in, wintertime, that's pretty air-conditioned.
The concrete company my dad worked for at the time needed a lab assistant, so I went to work as a QC lab assistant at the age of 16. Obviously, at the time, I thought I could do anything. I was invincible, and really had a steep learning curve, but found I loved it after my very first job. Like you're saying, everything you touch has got your name on it. The very first job that I took part in from a QC standpoint, the salesman was kind enough to take me out, even though I couldn't legally be on the job site because of insurance reasons. I was 16 years old. He ran me by the job, and I got to see this beautiful concrete frame building with tilt-up walls that I'd been part of, and it felt great. And that I was hooked. I was making $4.25 an hour at the time. just to date.
Yeah, let's not get into that because I talked to my youngest one about how much money he's making. I'm like, man, you have no clue. Yep. But I don't want you to sell yourself short. You said you're invincible. You could do anything. You still can. When you grow up,
yeah,
you can be anything you want to.
Absolutely, and I'm still working on that, but we'll see how it goes. But yeah, that's us, and thank you for joining us today, and we'll dive into the intro content today. And just before we get started, I want to let you know that we welcome interaction. So if there's a chance for you to comment, ask questions, those kind of things, we would love to see them. And we want to thank you for spending some of your time listening to two old concrete guys talking about concrete, where it comes from, and all those things. So I guess we need to dive in, don't we?
Yeah, might as well start with the history of it.
Okay. Yeah. When you're looking to pick a place to start, history is a great place to start. I mean, it helps us get a feel for where we've been, where we're going.
Yeah, and I mean, I know, like for us, we do presentations and we talk about the Roman concrete, and that's a big thing. You hear a lot of people talk about the Roman concrete, but there was some other people doing it as well. The Egyptians, for one instance, they were using gypsum and burning it, and using that to stack with their blocks or their cut rocks. And there's thought processes that's part of the pyramids.
Sure.
So we had the Egyptians there, and then we also had the Greeks as well. Mm-hmm. You had not just the Romans, but the Greeks were a huge influence on today's society and what they brought through. And they were using, they were burning their limestone to produce a quicklime.
Yeah.
And that was giving them some abilities to do mortar and put some rocks and things together. But, as we all know, once you started getting some fine soils and some of that earth and start mixing it with lime and water, you started getting something a little different. And that's what everybody's seeing with the Roman concrete.
Yep. And then the graduation from that into the pozzolans and other things, they began to perfect their concrete mixtures to be strong and last a while. And as around the first century is really when the Roman concrete started taking off with aqueducts and the Pantheon and other Colosseum, other structures that were where it's taking a shape of something more than mortar and more structural in nature. However, at this time, it's important to remember it's still unreinforced.
Right.
The dome at the Pantheon, for instance, it was the world's largest unreinforced concrete dome, and I believe it still holds that title. But there's ways around not having a reinforcement that the Romans used. I get asked a lot of times, "Hey, Brent, we need to figure out what the Romans did with their concrete because it lasts forever." And my response when I'm asked those questions is just simply, yeah, they did a great job, but they also don't have the exposure conditions that we have. So it's an ideal situation around the Mediterranean to have. In that region of the world, the concrete's going to last a while if it's quality, and they did some good quality stuff. So that's from the Roman construction when Rome, quote unquote, fell around in the 400s. After that, the Middle Ages rolls around, and what was going on in the Middle Ages?
Yeah, we got into a dark time for construction. We actually kind of started losing a lot of the information we had. What the Greeks did, what the Romans did, what the Egyptians did, we kind of lost it, and we were basically just bottoming out at just doing basically mostly mortar. And the materials that they were using at the time were nowhere near what it was done prior to. You still see some castles and things being built, but it was all rock. And it was not to the same stage as what you're seeing out of the Romans or the Greeks or even the Egyptians. And it was because just the lack of the quality we had. So we almost kind of lost that up until about the 14th century when it started kind of picking back up.
And that's when we start seeing some of the really nice cathedral constructions start coming in the 14th and 15th centuries and a little bit later. And the Lombards from Italy and other groups that are really doing high-quality masonry construction. And some of that was using, unfortunately, there's not a lot of records, but some of it was using some mortars that were sort of cement based and it's not Portland cement concrete like we know today, but they were.
No, that's further down the road.
Yeah,
I mean, you got some things going on there. I mean, and cement, like with most industries is we evolve slow, and sometimes we kind of forget where we came from, and then all of a sudden you'll see us take off, and you'll see a quick growth, and all of a sudden you'll see this huge boom. And we kind of seen that because, really our modern concrete kind of started around the 1750s, give or take, and then we started getting into, some different people looking at some different things and kind of almost reimagining or remembering what the Poslins were doing to it and started getting into what we now see as that. You start going into Joseph Aston and what he did, and that's where we got the Portland cement name from.
Yep, he named it Portland cement because he was near Portland, England. From what I understand, he was a mason who was looking for a better mortar, and he discovered that when he produced this limestone based stuff in a kiln and took several days to burn it back then, that when it came out, once it set, it produced a white colored material, rock-like in appearance, that very much resembled the white cliffs near Dover, England. Right. And so there was a town called Portland nearby, and so he called it Portland cement after the white color.
Now, not Portland, Oregon, but
right, yeah. And from there, seemed to be the key development that sort of launched an industry.
Right.
Because before that, it wasn't exactly Portland cement. We were working with different cementing materials, but Portland cement came around through the efforts of Joseph Aspen, and then others jumped on in a hurry and began making improvements. And then that brings us to really the late 1800s. You're looking at rotary kilns in Coplay, Pennsylvania. Was where the birthplace, and then the rotary kilns came out from in the Lehigh Valley, and they began making cement in the Lehigh Valley in Pennsylvania.
Now just
sending it everywhere.
Before,
else.
Just because some people don't, I know we'll get into it later, but a kiln is a way to process limestone and other ingredients. You heat it up and you get a clinker, and that goes into other things you got to do to create cement.
Yes, and that's a very important point. Is as you know, Josh, and I'll try to do the same for you. We're going to throw out terminology because the concrete industry has a lot of its own words, like any industry. That even though kilns is in the common use, it's most used in cement production. It's a large oven basically that rotates, and like you say, limestone and other materials producing that clinker, and then once the clinker's produced, they grind it into a powder, etc.
Well, and the rotary kilns also help speed up the production of cement. I mean, you can only go as fast as the materials are. So when you're looking at what Joseph Aston did at 16 tons of clinker and it taking several days, you're not getting a whole lot of cement out of that. So,
No.
you know, the advent and the industrialization of cement production led to the ability for concrete to start taking off. You know, and we're getting away from the rock, we're getting away from other things. You know, that now that we know that, you know, concrete is being used twice as much as all other building components combined.
Yep.
So it was that industrialization, that leap forward that we started seeing. So, you know, you start looking at in the early 1800s to middle 1800s to now is only 200 years. But look, you know, the steps we took from Romans and Greek to then was very small.
Yeah.
And then we started seeing what we could do with it, you know, and then you start looking at the 1870s, we started actually looking at reinforcing.
Yeah, and that is key to the story of concrete, if you will, because without reinforcing, we're very limited on what we can do vertically. Yeah, you've got to have some reinforcing or make some sort of allowances for movement other than in compression. You know, you put concrete in bending or you put it in flexure or tension, it's not very strong compared to its compressive strength. So we try to take advantage of that compressive strength. But the way that the reinforcing steel gives us an opportunity to provide some tensile and bending strength to the concrete. Tensile is just pulling apart of the concrete.
Right. And for those who don't know, I mean, you start looking at, there's a reason why, if you look at I don't want to say the eighth wonders of the world, but you start looking at, you know, the Mayan, Aztecian, Egyptian pyramids. There are pyramids for a reason, because that was an easy way to get height out of something, but you had to get so big.
But I thought it was aliens.
No, let's not go there.
Okay.
Just because History Channel does it does not mean, you know, we need to get down that pathway. Let the History Channel do what the History Channel does. But,
Okay.
I mean,
All right.
when you're really looking at it, that's the reason we did. And that's the reason the Great Pyramid was the highest, you know, the tallest structure for many, many years.
Yeah.
Because of that was a quick way to get height out of something and not have to worry about structurally doing something different, because you could build it up. Mm-hmm. You know, then you had like the Pantheon and the Colosseum and things like that had that curvature, but you're still looking at arch, and there's that capstone that's holding everything together.
Yep.
You're not relying on anything more than friction in many ways.
Yep.
So, you know, the fact that we started getting reinforcing allowed us to build quicker, faster, higher, but not use as much concrete either, because now you have other sources of strength coming out of it.
Yep. Perfect, man. That's exactly right. If you want, so once we began having reinforced concrete, so around, what was it, like 1912, I think, when precast prototypes began being made, if I remember
Probably
correctly.
a little bit before 1912.
Okay.
By 1912, the precast pioneers are really going at it. And when we say precast, understand we're talking about components that are made in one place, shipped to another place.
Yep.
A lot of what you see nowadays is ready-mix concrete that is cast in place. So you go get your foundations for your house or your building. You know, a ready-mix truck will come in. It's a concrete truck, not a cement truck. They are different.
Yes, even despite every toy company on the planet calling them cement mixers.
So, you know, you'll get those pulled in, and they have forms for them to go in, whether it's earthen forms or wall forms. That's what they're going into. But precast was done, and then, you know, by the time 1925 came around, the ready-mix industry was going full swing.
Yep. And during this time, in this time period, like 20s and 30s, did you know that Thomas Edison, or maybe even earlier, Thomas Edison in the early 20th century was making concrete furniture, and he had a concrete furniture company.
Really?
Yes. But that was
I wonder if that was like a light bulb moment that went off.
It was. I think it was a light bulb moment when he realized that nobody wants to move concrete furniture because lightweight concrete didn't come out till later.
No.
Yeah.
Well, I mean, even then, I mean, it probably wasn't reinforced and probably, thick and everything else, but durable.
Yeah, yeah.
Take a licking and keep on ticking.
Uh,
But, then we had other advents that came in. So the high frequency vibrators hitting the market in the late 20s, which allowed a dryer mix to be moved in place, to be consolidated, to start working and getting better construction out of it.
So this evolution, this movement of advancing technology when it comes to concrete really started hitting full steam ahead in the early 1900s.
Right.
And once I like to think of it a lot like, I don't remember the guy's name, but there was a guy several years ago that talked about computing power and how every so many years computing power doubles.
Right.
And if you remember back to when you had a computer in the 80s or 90s, the computers we have today my phone's more powerful than a computer I had in college.
Yes. Of course, back then yours was more of an etch a sketch, just turned upside down, shook it real hard to reformat it. But yeah,
along with an abacus, and I was good. But
kids, if you don't know what abacus is, go look it up on Google.
So you start getting ahead of steam, and people began realizing that we can make improvements to the concrete that we're making. And then as the need arises, as the old saying is necessity is the mother of invention, you're starting to build things like dams.
Right.
And when you start to build things like dams, something comes into play that maybe didn't really come into play too much when you're pouring slabs, pavements, and walls for buildings or columns for buildings. Now you've got mass concrete.
Right.
And that mass concrete's got some special considerations that they had to address, and they had chose to address it at the time because the admixture technology wasn't there yet, and we'll get into admixtures in a bit. But
Right.
So they had to make some changes to the Portland cement, basically.
Something about, and we'll get into why, but concrete does heat up for a specific reason. And when you get a large mass of concrete, it's going to heat up tremendously, which is when we started seeing like a low heat cements coming out. And then we started realizing that we had some aggregates having some reactions. So then we started getting a low alkali cements. Eventually, we end up leading to the 5 different types of cements that we see right now being utilized.
Yeah.
And we're seeing another advent with sustainability with getting the type 1Ls, which is a limestone cement.
Yep.
And there's some other ones that people are playing with to try to help out with our sustainability. So we're getting into that as times change, as we see things that would need to be moved, industry changes with it. Because we got to keep up because concrete's going to be placed every day.
Yeah, absolutely.
That's not going anywhere. So it's how can we do better for the environment and for sustainability. So we start getting into those type of things.
Absolutely, and the great thing is that it's an industry that continues to give back. And what I mean by that, I just want to encourage everybody: don't let some words that you haven't heard before. If you're new to concrete and you hear a word, then pause it, look that word up or whatever. We're going to do our best to put it in normal language terms, but I want to encourage you to learn about concrete just simply because the next generation that we're looking back and we're looking at a generation behind us that is gravitating toward other types of jobs than building things. Yeah. And I want to encourage those that have an interest in building things. Concrete is a great way to go. So I know that's kind of an aside, and it interrupted our flow as far as the discussion, but I wanted to point that out, that we need young people in our industry, and it's a fascinating industry, and it's going to keep giving back to you. You're going to continue learning. I'm 50. So
you're saying as much as me and you keep thinking we're the young guys, we're no longer the young guys?
We're not the young guys anymore, Josh, and not just that, but I continue to learn. And you continue to learn. It's a subject of study that will continue to give back for a lifetime. You're never going to know everything there is to know about concrete.
No, matter of fact, if I ever get to the point I think I know everything about concrete, please smack me because there's just no way.
Yeah, I'm looking forward to that day, so I have an excuse. All right, so moving on to hydration.
Well, you kind of segued when we started talking about the mass concrete and the heat effects of it, and why does concrete heat up?
Yeah, so what you have is it all starts with the Portland cement, like you're talking about. And when we combine Portland cement with water, there's a reaction. that occur. Sorry, many chemical reactions that occur. But collectively, they're known as hydration because the cement is reacting with the water to form a number of reaction products that allow that concrete to set up, harden, and gain strength. During that reaction process, it's an exothermic process, meaning that it gives off heat.
Right.
So you're producing, and you can dig in as deep as you want on the heat of hydration and all the science behind it. But just the simple thing to consider is that it will be warmer than the temperature of the water and the temperature of the cement. The combined is going to be warmer than each individual temperature because it's putting off some heat. And that can be a problem in things like mass concrete, like in the dams we were talking about.
Yeah, and if you want to learn a little bit more about mass concrete, what to do, ACI's got a whole committee and documentation for it.
That'd be C309, I believe.
Please let's not try to confuse them because there is no.
Sorry. Yeah, man.
Please don't do that again.
I didn't mean to do that.
Especially when you said what you did. Specifically, though, that C309. That's a ASTM curing compound that has got nothing to do with mass concrete.
Sorry, ASTM. The ASTM committee C309 is curing compound.
No.
The ACI committee 309 is going to be your mass concrete.
No.
It's not?
No.
Okay.
You're thinking 305, 306, and 308, which is hot weather, cold weather, and the curing committee.
Well,
you got it. You got a computer right
I may
there.
be
Why don't you just
wrong.
look up mass concrete?
I'm going to. You keep talking to us so our viewers and listeners don't get bored.
Nah, I want to see them awkwardly look at you while you.
Oh, that's fine.
And for those who are on just the podcast audio, you're not missing anything.
All
Just
right.
be honest with you. But anyway, the heat of hydration does heat up, and when you get into mass concrete, you get in some reactions that are not necessarily good for concrete. So you start trying to get the equalization of that temperature movement and dissipation out.
All right. So I'm new to tablet use. Let's see here. Yeah, so I totally missed that. So ACI 309R is going to be your guide for consolidation of concrete.
Yep, not mass concrete.
I believe it used to be mass concrete, but that might have been 30 years ago. Okay, so never mind then. Let's see if we can pull up the correct one, just in case someone wants to. My space bar on this keyboard doesn't work. So dead air is our enemy on a podcast. So,
well, you're the one that started down this pathway of things that you weren't expecting for. I mean, I'm not sure.
We'll get
why
Fred to
you
cut
got
all
into it.
this.
I don't know that he can.
All right. So mass concrete is going to be ACI 207.1R-05 Guide to Mass Concrete.
Yeah, like I said, not.
So I was only off by 102.
That's a pretty big one though.
Oh yeah, I guess so.
So let's not do that again.
All right. Well, I did that so our listeners will know that we're human and we make mistakes.
If they've watched any of our videos, they know we're human and we make mistakes.
All right.
This is not anything differently.
No, it's not.
So, but let's just start out. We got into hydration reaction, a little bit of the Portland cement. We got into that because we started talking about the history of cement and concrete and what it leads to. But
Yes.
cement is not concrete, as we alluded to.
Right.
So let's just hit basic levels so everybody's on the same playing field. We're not playing in a big ballpark. We're playing in a Dizzy Dean baseball field. What is concrete?
Oh, yeah. Concrete at its most fundamental form. And I use fundamental because I don't like the word basic, because basic was a competitor of mine when I was a young dude. But anyway, so in its fundamental form, you got rock, sand, cement, and water.
Right.
And without one of those then you don't have concrete anymore. So you've got something else. If you have, I mean, you still have a type of concrete. I guess you could have pervious concrete with just rock, coarse aggregate, cement, and water. But and you'd have a grout or a mortar, depending on the
Right.
movement of the material.
Let's
If
not
you-
get into all that.
yeah.
Simple, basic concept.
rock, sand, cement, and water.
Thank you.
Yep, that's it. And it was done by shovels back in the old days. Right?
Yes, 3, 2, 1.
3, 2, 1.
And for the listeners who don't understand that, 3, 2, 1 means what, Brent?
3 shovels of rock, 2 shovels of sand, 1 shovel of cement. Add water till you get it to the consistency you want it, and put it where you want it. And that's the old way of doing things. And some homeowners and farmers and other folks still do concrete that way every single day. They'll buy their own bags of cement, get their own rock and sand, and mix it up in a wheelbarrow.
All right. So basically, you get it in there, and we're going to get into, so as you add your sand and your rock and your cement, and you add water to taste.
Yeah. Don't eat concrete, by the way.
Yep, please don't.
It is high in minerals and can be high in fiber. We'll get into that later, but don't eat it.
Seriously. But when you start mixing it up, that reaction,
It's bad for the teeth.
yes. That is not the cake you want to eat. But as you're mixing it in that fresh plastic state, that is the ability that we can use it, the workability that we want
Yep.
to place it. And depending on the way you mixed it, how you mixed it, the heat that's going on, there's a lot of things going on there that lets us know how long we have
Mm-hmm.
before set starts taking place.
Yes.
And that set is when it needs to be down.
Yes.
It needs to be left alone.
Yes.
It needs to start getting to that hardened state that we want.
Correct.
So, kind of go into that a little bit as to, we're talking about sets.
Yep.
And you'll hear it from a finisher standpoint. You'll hear it from other people. People who don't understand concrete might not understand when we say set, what that means. But we're really talking about 2 different sets, initial set and final set. Brent, you played in the ready mix company for many, many years. What?
Yeah, so they're kind of arbitrary terms, but there is a test that you can run for initial and final set. Initial set, a good way in the field, if you're in the field, a good way to know your initial set, your initial set is you can walk on the concrete without leaving an impression with your shoe. In the laboratory, there's a test that involves we call it a needle, but it's not as small diameter as a needle. It's going to have a much larger diameter, but it is a set time needle.
Right.
And that needle is going to measure the resistance of being pushed into the concrete. And there's an indication in the lab how many, you can run a test in the lab and see how many hours it takes for the concrete at a certain temperature to get to initial set.
Right.
We refer to that all the time as just set time.
Right.
Final set is another level with a smaller diameter needle.
You made fun of me for my uses of Chattanooga not too long ago.
Oh,
and you can't
said
say
it right.
Yeah, I know.
All right. The smaller diameter.
Diameter.
English.
Say it slowly.
The smaller diameter needle used in the final set is an indicator of that concrete is where it's going to be. It ain't moving anymore. It's going to do what you want it to do, hopefully. It's hard enough. It's beyond the troweling process. It's beyond...
Okay, that's kind of where I was wanting you to go at. I'm great for the needles and I'm great for the laboratory stuff. But for most of us,
the field
is, so when a finisher talks about set times and his, if he's got a concern about it, that's kind of where I was going for. What if you're out placing concrete or you're out walking around on the job site and you see concrete being placed?
Yep.
The initial and final set, what are we looking at? Where does that come into play at? And how does that?
Yeah, great question. And initial set's going to be during the troweling process. You're usually going to put some float pans on the concrete sometime around the time you can put a 1/4 inch impression or so with your boot when you're walking on the concrete. So it's the troweling process is going to start a little before initial set, but not much. You want that bleed water to be gone. And we'll get into that a bit. But so initial set's going to occur about the time you're not leaving tracks in the concrete anymore. And,
right.
And then around the time that you're finished with troweling, when you're finished with and when I say troweling, if you're new to the concrete, again, terminology, don't mean to be throwing weird words around, but you see the helicopter-looking whirly birds that people walk behind? That's a machine trowel on a concrete job.
Or even you're hand troweling, you're still waiting for it hard enough to do certain things. Let's make it simple.
Yep.
2 different top floats.
Yep.
The pan float or a more flat surface is for around the time initial set to get everything started, start smoothing everything out, start getting everything level. Then you get your still trowel, and that's when you're trying to give you that wonderful, beautiful look that every finisher wants to get to. Let's just leave it as simple as that.
Sure, and people leave. So once final set happens around that time frame, you're going to see a change in that concrete surface to where if you take it far enough, it's going to be reflective and those kind of things in a slick finish.
You'll get it's what they call burnish.
Right.
You'll get blackened look to it. But okay, so let's just get through that. But you mentioned earlier about adding water.
Yeah.
So we know that cement reacts within water. We know that's how concrete gets its wonderful properties that we love. It gets hard from it. When we're talking about water cement, and we start looking at how much water to cement we need, we know that water that we put into the concrete mix is more than it needs to react.
Yep.
But we also know back in the olden days, they weren't putting enough water in it, and that's why we're having some of the issues we had with older concrete. Nowadays, we got water going in, but there is a wonderful indication when you start seeing that water in cement and how much water you put into cement and the attributes you get out of your concrete.
Yeah. And the general guidelines are they hold true for the most part. You're going to see water to cement ratios being talked about. You're going to hear about water to cement ratios, or water cement ratios is the way it's normally discussed. All that is the pounds of water in a cubic yard of concrete divided by the pounds of cement in a cubic yard of concrete.
Or cementitious.
Right. And you're going to get a number that's somewhere typically in the neighborhood of 0.30 up to about 0.60. And that number is going to be an indicator to you of where the strength of the concrete is going to be, compressive strength,
right,
and about where the durability potentially of that concrete could be, because we know that the more water you add for a given amount of cement, the weaker that concrete's going to be and the less durable that concrete's going to be. So water to cement ratio is one of the key concepts in concrete, one of the basic fundamentals. Look, I used the word basic.
Yes, you did.
To give you a prediction of what that concrete's going to do. And it's what all of the concrete design methodology is based around. Water to cement ratios, where you're starting at.
Right. So you kind of talked about durability for just a minute, and that actually rolls into one of the other things that came out of the concrete industry and to make concrete better is admixtures.
Yes, absolutely.
And you got different admixtures that do different things, from a plasticizer that allows less water to be put into the mix and allows it to still be fluid and to move, get consistency. Then you got air entrainment, which was being introduced into concrete so that the effects of freeze-thaw and the exterior concrete and the things that happen there starts mitigating some of those things.
Yep.
You got viscosity modification, you got all kinds of things going on, and there's a whole group of people that deal with nothing but admixtures throughout their whole career.
Yes.
But there is a lot of that, and we'll get into more about what those admixtures look like and exactly how they affect the concrete and its durability. Yep. And we mentioned the durability a couple of times. I mean, all in all, everything from the beginning of concrete to now, everybody's trying to make concrete last longer, look better, and to maintain sustainability. The less we have to repair, the less we have to replace, the more sustainable that first placement of concrete is.
Yeah, absolutely. And that's something that I've been really trying to talk about as much as I can, is if we can make a structure that's going to last much longer, then you're saving that greenhouse gas emission cost of having to rebuild that structure before you want to. Right. So, and there's all sorts of, exercises in math, the mental gymnastics you can do to reach the different numbers that you want. I don't want to get into all that right now, but the idea is that if we build it right the first time,
right,
in general, you're going to have a kinder structure to the environment than if you
right. So basically, we're looking at if your strength's right, whether it's compressive or flexural, depending on what your component of concrete is supposed to do.
Yep.
If we design the concrete or protect the concrete from resistance to environmental or chemical attack, if we try to mitigate the amount of cracking that happens inside the concrete, and all of that comes down to keeping the water out of it.
It does, yeah.
You know, water takes in a whole lot of really bad things in the concrete, and once it hits that reinforcing steel, more things can go wrong. So if we start mitigating those things, we get better durable concrete.
Absolutely. And the list of things that can attack concrete is long. And there's a lot of those environmental and chemical factors that we have to consider. For instance, let's just say, Josh, I'm the client, and I own a company that makes car batteries.
Right.
And I'm going to be building a warehouse, a brand new warehouse where I'm going to be storing car batteries. What sorts of considerations would you think I would need to take?
No, I'd start with your mix design and start looking at what you're trying to do, and then look at, you know, what kind of acid attack you got. And there's ACI Body 201 that talks about, you know, that and gets into acid attacks and what you need to do to, you know, mitigate that acid attack to it. Because
Yep.
the one thing you don't want to do is try not to get the acid on the concrete, but if it's there, you know, what's there to help slow that acid attack.
Yep.
You know, so there's all kinds of things you got to do. So really it's find out what you're putting that concrete under, designing and protecting the concrete with products that's going on it to help mitigate those circumstances of environmental attack, chemical attacks, whatever it is.
Right.
You know, so again, the more we can do to make your concrete last longer, the more durable it becomes, the better it is for everybody.
Yeah.
And we'll get into more of what those look like in other podcasts, which also will get into the stress and failure of concrete and why each one of those can help, can actually hurt your concrete and what to do to help fix them.
I read a study about 15 years ago where there was a place in Scandinavia that was having problems with pigeon poop causing degradation of their concrete bridges in one of the cities in Scandinavia. And just to put it into perspective, how probably most people wouldn't ever think, well, pigeon poop's going to hurt my concrete. But there were so many pigeons at that particular location that, yeah, it was absolutely eating the surface of the concrete off, and it was exposing the reinforcing steel, which was then causing reinforcing steel corrosion because then it's exposed. It was bad. So the point just being that there's a whole lot of different things that can attack concrete. So the fun part of the job that you and I have is figuring out, okay, how can we help people protect their concrete and that
Right.
like that. So, but great discussion today, Josh, and that gets us close to the end of today's episode, I think.
Pretty much. I think that's pretty much it. I guess, you know, next episode we'll talk about the fresh concrete, and we'll make it simple. Let's just talk about the workability of concrete.
Yeah. Workability is super important, and because if you can't get it to its final resting place, then you're not going to have the concrete look that you're looking for. It's potentially not going to provide the function you want it to perform. So, looking forward to that discussion, and we're looking forward to your questions, dear listener. Your questions, comments, anything you'd like to send in, and hope you've been entertained and enjoyed this podcast. And we'd like to invite you to the next one.
From our home to yours, we'll see you next time.
Thanks for joining us for Two Wheelbarrows and a Place We Call Home with Josh Carroll and Brent Rollins.